Hi, good morning, students. Today I'm going to explain about preparation of alkanes. So we'll start the class. Preparation of alkanes. We'll discuss about. Okay. So coming to the class. So what is alkane? So basically, for example, if you see the alkane, it should obey the some parameters. Like it should contain the single bond, and hybridization for the alkane is sp3, and bond angle, whatever the parameters, bond length, bond order. So these parameters is enough. For example, if you take any molecule, if it is having only single bonds, that is comes under alkane, and all alkanes have the sp3 hybridization. And coming to the bond angle, it should be like 109 degrees, 28 per minute, and bond length it be 1.54 angstroms. Basically, length will take it in angstroms. Bond order should be 1. Why should be 1? Because of the number of bonds between carbon and carbon, it should be 1. Okay. So this is the basic introduction about the alkanes. Coming to the some, we'll go about like whatever the some examples of the alkane. Okay, we'll discuss one by one. So take a few examples for the alkane. Examples. If you take like for example, let's take. If you see here, this is the one example. Ethane. If you see here, in between the carbon, only we have the only one bond. Okay. So this is one example. Okay. So so today our topic is about to preparation of alkanes, right? So the preparative methods for the preparation of alkane is one is Wurtz method. Wurtz method. Okay. And by the reduction. By the reduction also we can prepare it. Okay, and we have the some more preparative methods. So we'll discuss. So and another method is by the decarboxylation. Also, we can prepare it by decarboxylation. Okay, and in a Wurtz reaction also we can prepare it, and reduction by reduction also we can prepare, and from the Grignard reagents. Okay, from Grignard reagents also we can prepare it. From Grignard reagents. From Grignard reagents. And hydrogenation of alkenes, and by hydroboration of alkenes. Okay, let's discuss one by one in each reaction. Okay, first we'll explain about the Wurtz reaction. Okay, so what is Wurtz reaction, and what is the key steps here, what is the reactant, what is the product, we'll discuss one by one. For example, if you take Wurtz reaction in the sense, so in the Wurtz reaction, basically we'll take sodium is the reagent. Okay, here sodium is the reagent. What is the reactant? We can take it here is the alkyl halide. For example, let's take the alkyl halide is the reactant, 2 moles of alkyl halide. Let's take and 2 moles of sodium. Okay, this is the reagent. So when reacts with the sodium with the alkyl halide, it forms the alkane. plus 2 NaCl. Okay, so this is the reaction. Basically, we are using in Wurtz reaction. So in that case, we are using the dry ether. Okay, dry ether. What happen in case if you are using wet ether, in the sense it will make a alcohol. So that's why we are considering dry ether always preferred. In case if you are taking the wet ether, right? So I already mentioned it will form alcohol. Coming to the reduction part. Okay, we have a lot of reducing agents. I will discuss few of. Okay, if you see here, we can use the lot of reducing agents. I will discuss like one is zinc by zinc plus this here. This is one of the reducing agent. If you see like zinc plus acetic acid, this is also one of the reducing agent. If you see in like zinc couple, this is also one of familiar zinc and copper coupled by some methyl alcohol, ETOH also we can say that. So this is also one of familiar reducing agent, and red phosphorus by HI. This is also one familiar reducing agent, and we can also like AI by HG. This is also one of familiar reducing. These are all very familiar reducing agents. We can use it anyone. Okay. So basically, if you take alkene, okay, if you take alkene in presence of some reducing agent, you can take it any like nickel. Okay. If you take the nickel, what will happen, right? So basically, it will add the addition of hydrogens. Reduction is basically addition of hydrogens. It will add the hydrogens to the particular reactant. Finally, it will form alkane. This is one of preparative method in a okay to make a alkanes. So one more this thing by carboxylation, right? So in carboxylation, so coming to the carboxylation, let's take sodium acetate. Okay, let's take sodium acetate CH3COO Okay, what will happen, right? So if you take the sodium acetate in presence of soda lime, okay, soda lime. So it will form the alkane by losing of CO2. Okay, by losing of CO2. So basically the reaction soda lime in the sense CaO. Okay, CaO from Grignard reagent. Okay, so how the reaction in presence of Grignard reagent, we'll discuss that one as well. If you take the Grignard, I feel like you already know about the Grignard reagent. In case if you don't know, you don't worry, I will explain. Basically, Grignard reagent in the sense CH3 MgBr. Okay, here magnesium is the metal, and this is the halogen, and this is the alkyl group. Okay, so we'll take the Grignard reagent CH3 MgBr. Okay, this one reacting with any water. Okay, it's true. What will happen? So we'll get one alkane, and next one is the byproduct MgBrOH. Okay, this is so coming to the hydroboration of alkenes. Okay, hydroboration of alkenes is something different. So this bit little bit tricky, but in a simplest way I will explain. So hydroboration of alkenes means in this case first you have to take about one alkene. That is let's take like simplest alkene like CH3 CH double bond and then CH2, and first you have to do the hydroboration. In this case, like hydroboration in the sense you have to react like B2H6. You have to react with B2H6. Finally, you will get it like the compound like this. CH3, CH, okay, CH and CH2 and then CH2. You will get the product like this. Okay. So, I mean 3B. You will get like this. Okay. So after the when you are reacting with this thing, after you have to react with acetic acid. Okay. So after reacting with the acetic acid, you will get the alkane 2CH3 and CH2 and then CH. These are the preparative. So finally, you will get the alkane. So these are the preparative methods for the alkene. One is Wurtz method, and second one is the by reduction, and third one is the by carboxylation. I mean decarboxylation. You have to. This is decarboxylation. D you have to mention decarboxylation from Grignard reagents and from hydrogenation of Alkenes. Thanks for watching my video. If you like the video, please subscribe my channel. Thank you. Thank you, students.